audible loud and clear?
Yes.
I apologize because my voice is slightly choked today because I may be a little unintelligible to you, and I expect that you try to just decipher my voice. Anyway, hello everybody. I'm 𝐷𝐞𝐫𝐢𝐚, General Secretary of Healthy Climate Initiative in its India operations. A very warm welcome to this thought-provoking session hosted by SCI titled Marine Permaculture, a Scalable Solution for Climate Resilience and Food Security. At a time when our planet faces critical challenges in respect of climate change, declining marine biodiversity, and growing food insecurity, this webinar shines a light on one of the most promising, scalable, and nature-based solutions of our time. We are truly honored to be joined today by Dr. Brian von Herzen, founder of Climate Foundation, whose groundbreaking work in regenerating kelp forests and ocean ecosystems is redefining how we think about climate repair, carbon removal, and food sustainability. His efforts also align closely with India's ambitious vision, including Government of India's goal of 30-fold increase in seaweed production, an initiative that can transform livelihoods and ecosystems alike. This is not just a science, it's a mission for a better world, and we are privileged to explore it with you all today. And with that, let's begin. I now invite Mr. Rituraj Phukan, our moderator, to introduce our esteemed speaker and set the stage for today's discussion. Thank you.
Thank you, Mr. Ghoshal, and welcome everyone to this very interesting HCI webinar. Dr. Brian von Herzen is the founder and executive director of the Climate Foundation, which upholds the vision and the mission to regenerate life in the oceans using marine permaculture, a new technology, evolving technology, I think, which has great potential. As the executive director, Brian leads Climate Foundation's large-scale seaweed marine culture programs to develop sustainable food, feed, and fertilizer value chains, provide ecosystem life support, and sustain blue carbon sinks. Without further ado, I would invite Dr. Brian to go ahead with his presentations. And at the end, I hope everybody will be taking notes, and at the end, we can take some questions. Thank you very much.
Thank you, Rituraj, and it's a pleasure meeting with you all today. We're at an auspicious time when we have great challenges, but also great opportunities. I think Prime Minister Modi's initiative to increase seaweed production in India from 34,000 tons in 2024 to 1.1 million tons of seaweed production in 2025 presents a huge opportunity for us to consider how increasing our food security on sea as well as on land can have a profound effect on the food security for the Indian subcontinent and beyond. I think this presents a big opportunity in a time when, in many ways, the problem of climate disruption is really a problem of food security for billions of people and also for millions of species who depend on, I would say, stewardship of our planet by humanity, like it or not. I'll share my slides and talk with you about our intervention of marine permaculture, which we have developed as a flagship in the Western Pacific, including the Philippines and Australia. And now, this year, for the first time, we have staff in India ready to deploy marine permaculture in India this year. So I'm looking forward to sharing this with you and discussing what are the ramifications for ocean stewardship across the Indian Ocean. Thank you. Here's our slide deck. We call it marine permaculture to help regenerate life in the ocean. Our problem statement is simply that 93% of global warming is going into the ocean today. And this heating, especially for the tropics, is causing extreme survival challenges. Profound effects across the tropics. By 2070, 3 billion people will live in uninhabitable zones, the black regions. This is a profound realization, particularly in the Indian subcontinent. Which part of India are you living in? It's not just India. Even in my new adopted country of Australia, we have called the North Australia heat engine. Major portions of Australia also will become uninhabitable by 2070. So this is a profound realization. If half of India becomes uninhabitable, what will we do? How do we address the needs of these 3 billion people and others? These are the key questions that we want to be able to address today in a timely way, quickly enough. So our vision at the Climate Foundation is to reduce, remove, and repair, embracing the work of our colleagues at the University of Cambridge and elsewhere around the world. By reduce, we mean reduce emissions while ensuring food security for billions of people and millions of other species. Remove is about removing carbon from the atmosphere and other greenhouse gases and sequestering it in the deep sea or in the soils of our planet, where we've done biochar work over the past decade with our engineering colleagues in Bangalore and have developed the world's first biochar reactor that can turn high moisture biomass into biochar that it can actually help to regenerate depleted soils across India with not only higher carbon content, but also healthy soil microbial communities and compost. And finally, the third R is repair, and that is climate repair to regenerate healthy ecosystems on sea and land and food security for all. The ocean, as I mentioned, is particularly susceptible. These red regions represent less upwelling, and in a warmer climate, this presents less nutrients for the deep sea. It's estimated for every 1 degree of warming across the horizontal axis, we see a 5% decrease in the total biomass in the oceans. So right now, we are already, the oceans are now 1.6 degrees above pre-industrial temperatures, which places us right here. And it means that we are more than 5% loss of biomass already from this effect, not to mention overfishing and other problems. In places like Tamil Nadu in India, we've seen production losses of 60% in the marine heat waves over the past decade. And this is a severe problem made worse by the ocean warming. And so we offer initially, as an approach, our marine permaculture solution, which this is a picture of a drone picture, actually, of a 1,000 square meter system. We've now grown even larger, and nature has taken up the habitat with squid eggs, with turtles, with marine fishes. And our goal is to scale to 1 hectare size. We're 1/4 of the way there already. And we even have a little sea turtle up here in the top left who's living near the platform. So the platform uses seaweed like a sponge. At night, we lower the seaweed down below the thermocline below the nutricline into cold, deep water, where it soaks up the nutrients in the deep water, like a sponge, nitrate, phosphate, micronutrients. At sunrise, we return the seaweed platform to the surface of the sea, where it soaks up sunlight and carbon dioxide in the top meter of the sea. And thus we get not only the increased productivity, but also the carbon removals in the top meter. 1/4 of the seaweed falls off the platform during growth, and I'll describe in more detail later how that contributes to the carbon removal. And this is a picture of our 2,500 square meter platform, 1/4 of a hectare now, the largest submersible seaweed platform on the planet with deep cycling each night. The entire platform goes down with the 4 buoys in the corners, and each day the platform comes back to the surface to get more sunlight. Now, I know in the Bay of Bengal, there are many problems with typhoons, cyclones, and we experienced a Category 5 typhoon just a few years ago in December, and it hit the city of Cebu, right where we were located. But our platform, we lowered 5 meters below the surface. It's depicted behind me in the video. And not only did the platform survive, but most of the seaweed was still on the platform after the typhoon. And we were growing seaweed the day after the typhoon. And 3 months later, we provided a 1/4 ton of seedlings to our neighboring communities so that they could reseed their seaweed farms and restore again. So this is how, with marine permaculture, we can be typhoon resilient and also help make the crops more resilient as well. Our first product is called a Big Grow Seaweed Foliar Biostimulant. And what's significant is that we have seen 15 to 30% higher yields, very conservatively, with 20% less fertilizer. On rice, we've done almost 100 field trials with rice, and the results have been profound. In fact, in 2023, we measured how many sacks of rice could we get for every sack of fertilizer. And the test regions with the biostimulant were 2 to 6 times more sacks of rice for every sack of fertilizer. Now imagine what that means for the Indian subcontinent, where oftentimes regions can be limited in fertilizer or other aspects, and the productivity gains are enormous, especially in depleted soils, especially when there's not enough fertilizer to go around. Not only in 2023, but also in 2024, we've seen these profound effects of 2 to 6 times more fertilizer-specific yield, sacks of rice over sacks of fertilizer, than in the control regions. So this is a great result for terrestrial food security as well. Part of the function of the seaweed foliar biostimulant is to increase drought resilience and heat resilience. And thus it has a profound effect on terrestrial food productivity as well as the marine food productivity. Now, we talked about the 3 R's: reduce, remove, and repair. And this slide shows how we do the reduce in agriculture, because we reduce the amount of nitrogen fertilizer it has to be produced. That saves 12,000 tons of CO2 equivalent per square kilometer of marine permaculture per year. And if you have 20% less nitrogen fertilizer, then you have 20% less nitrous oxides being emitted from the soil from those fertilizers. That enables another 10,000 tons of reduced and avoided emissions per square kilometer of marine permaculture per year. But then finally, because 1/4 of the seaweed falls off the platform during growth, we also get a carbon removal, a true blue carbon sink, totaling a net total of up to 30,000 tons of CO2 equivalent per square kilometer of marine permaculture per year. And so I'll describe how we can take this natural algae bed ecosystem of tropical seaweed forests such as those that grow off Tamil Nadu, off Lakshadweep, even Gujarat, and the Bay of Bengal. And if we can apply this ecosystem to this vast area of open ocean, some 65% of the planet, we can multiply a large percentage of the Earth's surface times the highest productivity on the planet. We get 2,500 grams of carbon fixation per square meter per year, higher than even the Amazon rainforest. It's really surprising. And so we can get a lot of carbon removal from this process. And as I mentioned, a quarter of the seaweed falls from the platform during growth and sinks 1,000 meters a day to the abyssal sea, where it remains for centuries, or in the case where it finds calcium carbonate sediments in the seafloor, it forms after the microbes and the fish have eaten it. They form some carbon dioxide. The carbon dioxide interacts with the calcium carbonate sediments to form calcium bicarbonate, which is dissolved in the ocean for 100,000 years. So this is a profound carbon removal approach that's using the deep sea sediments with no mining, no transport of rock dust. This just happens in the sea as a natural process. So if we give nature half a chance, she'll rebound exponentially by restoring the natural process of the biological pump in the ocean. To give you some feeling for the magnitude of this, all the carbon in the atmosphere is represented by the black square. 1/3 of the carbon in the atmosphere is from human activities over the past 2 or 3 centuries. And our challenge from a carbon removal standpoint is to take that 1/3 of the carbon in the atmosphere and distribute it throughout the middle and deep ocean, represented by this gigantic blue rectangle representing all the carbon in the ocean today. So if we took all that third of the carbon and put it into the middle and deep ocean, it would change the carbon concentration in the ocean by only 1 or 2%. That's how profound the biological pump is in the ocean today. So it's a nature-inspired and nature-based approach to do the carbon removal. And of course, we do this in steps. We've been working for the past decade from phase 1 through phase 2. We finished phase 3, 100 square meters, and it went to 1,000 square meters. And now we are working on this next phase. The timelines have changed a little bit, but our determination has not changed. And we're around now 2,500 square meters on the way to 10,000 square meters. Better late than never, right? So we hope to scale to hundreds of hectares across the Indo-Pacific. And we look forward to working with our Indian partners. And we are measuring with our university partners the carbon cycling underneath the platform in the Philippines this year. We're in the 2nd year of our carbon cycling study. And at the end of this year, we'll have measured with underwater gliders, with sediment traps, not only the seaweed, the daily biomass growth, but also the daily fall off of seaweed into the sediment traps, into the deep ocean, where it can remain for 1,000 to 100,000 years. At the same time that we're measuring the daily growth rate and the daily fall off rate, we are also taking daily drone pictures, like the one I showed you previously, of the entire seaweed array. And this will be used thanks to a grant that we received just in the last few months from the Bezos Earth Fund Greenhouse Gas Removal, Greenhouse Gas Innovation Award. We will train a machine learning model on the daily pictures and the daily biomass growth and the daily carbon removal to train the machine learning to recognize, not by weighing seaweed, but by images like the one behind me from the drone of the red seaweed and the green seaweed that's growing each day. And if you measure each day the growth, and when there's a big storm, you can also measure how much falls off. And that daily growth rate and daily carbon removal rate is exactly what we hope to measure. This will lower the cost of carbon monitoring, reporting, and verification by an order of magnitude. And we're so grateful to the Bezos Earth Fund for that support. I also would like to say that when it comes to our scaling, we have just received an award of $90,000 from the CO2 Foundation to scale from our present 1/4 hectare to 1 full hectare over the next 18 months. And so we're very honored to have received this award, this grant. And it means over the next 18 months, we'll get it to our full hectare scale. So we're very grateful for that one. And ultimately, it's about building value chains. It's about going from the marine permaculture platform through a transportable seaweed biorefinery that was inspired from our biochar reactor developed in India over the past decade, once if by land, twice if by sea, and will produce the biostimulant for rice, mango, all the flowering plants. We'll have food and feed ingredients from the dry pulp of the seaweed, and we will measure the carbon removals as well as the avoided emissions of the seaweed intervention. So that addresses the reducing of emissions through agriculture and the removal of carbon from the atmosphere through the cultivation of marine seaweeds. But now I'd like to talk with you about the third R, and that is climate repair. Now, I was very impressed to learn that in the 𝐊𝐴𝐽𝐵 Islands, nearly a dozen islands have a deep seawater system that takes the deep water. This example is from another place, but still the same principle applies. Takes the deep water in and reaches shoreline. And at the shore, they're using the cold seawater for the creation of fresh water for 𝐊𝐴𝐽𝐵 Islands, and potentially in the future, air conditioning for buildings in these islands. Now, this is commercial today in half a dozen cities around the world, including Toronto, I think Sweden, and French Polynesia. And the 𝐊𝐴𝐽𝐵 Islands are using it for fresh water. So there's an opportunity to use some of this upwelled water also, not only for fresh water, not only for cooling our buildings, but when we go back to the reef, we can cool off the corals and keep them from bleaching. And then finally, this warmed deep seawater has nutrients that we can use to irrigate the seaweeds and restore the productivity offshore of these seaweed habitats. So we have proposed this and are now beginning with our partners in 𝐊𝐴𝐽𝐵 to plan for a system that can utilize some of these resources to actually develop a seaweed nursery in the 𝐊𝐴𝐽𝐵 Islands that could ultimately include some of the deep sea water, as well as the optional coral cooling that could actually address thermally induced photobleaching that is occurring on the reef today. And so from that perspective, we are so appreciative of our team across the world, starting in the Philippines and now also in India, and also our partners. And finally, I do want to mention another really key aspect, and that's what we touched on with the Healthy Climate Initiative webinar in December, and that is the role of marine permaculture to actually re-brighten our planet and cool some of the critical cities from India to Singapore to the Philippines in the tropics. I'll just forward to the relevant areas. These are some of the carbon removal slides. And the question is, how do we address the dimming of ocean planet Earth? Sadly, our planet is 0.5% dimmer than it was just 20 years ago, as measured by the NASA Ceres satellite and the Big Bear Solar Observatory. since the year 2000, we have seen a dimming of the planet of at least 0.5%. This has occurred for several reasons. Not only have the ice caps gotten smaller, but also these marine clouds have gotten fewer and farther between. And that means more sunlight reaches the dark sea and is not reflected by the clouds. The result is unprecedented ocean warming. The sea surface temperatures have gone up to this high level in 2023 and have remained high throughout 2024 and 2025, way up here. And it's an unprecedented level of warming. In fact, this picture, I believe, shows since the 1950s, the ocean temperature is measured by the diameter of the circle. As you can see, in recent years, it's gotten bigger and bigger and bigger through 2024. This is what we're seeing by climate disruption. It turns out there's a precedent. The ship tracks going across the North Pacific have had a profound effect on, increasing and rebrightening some of the tracks. Unfortunately, the International Maritime Organization curtailed the sulfate aerosols, but you see, this wasn't an inadvertent trial that actually showed us the way, and that is there are benign aerosols, not the fossil fuel sulfates, but sea spray and biogenic cloud condensation nuclei produced from algae. Microalgae and also macroalgae seaweed produces some of these. But anyway, I'm getting ahead of myself. This warming that's occurred since the year on the left, 1970, this is showing January at the top and December at the bottom. It used to be pretty cool climate, blue, neutral colors. But since 2015, the big green arrow here, this is when we started seeing the IMO regulations changing. And now we see redder and redder, hotter and hotter conditions until in 2024, look, it's all red. I mean, it's just, it's not going back. El Nino's over. But, never fool Mother Nature, right? She's not going to be fooled in spite of all the pronouncements. We're seeing a really extreme and unprecedented temperature rise, which is having devastating effects on the ecosystems of ocean planet Earth. And they also affect civilization with the typhoons, the cyclones, here the hurricanes crossing just in 2024. So many hurricanes, not to mention the Bay of Bengal and the Arabian Sea are at risk with ocean warming, with the increased temperatures. These papers, just very recent, 2018, talks about the Bengal Sea surface temperature and the Indian monsoon simulation. Now, what concerns me is Dr. Sumitra's experience of the monsoon delay. Normally arriving in June, which is one of the hottest months anyway, the monsoon clouds reflect the sunlight in the Indian subcontinent and enable a cooling rains to keep June and July cool. But when the monsoon fails, then we have the untenable, uninhabitable surface temperatures through June, through July, and even into August. And so we have an opportunity to use biogenic cloud condensation nuclei and even sea spray to restore the monsoonal clouds of June and July, bring the temperatures back to normal. Because, this whole climate disruption, this climate repair is a convenience for the global north, but it is a necessity for those of us at lower latitudes. It is a matter of survival for humanity and for the millions of species that cannot vote. We're very grateful to the X Prize for Carbon Removal for having recognized this work. We're grateful to the CO2 Foundation for helping us scale to a hectare. And we're grateful to the Bezos Earth Fund for enabling us to develop the carbon monitoring, reporting, and verification standards that can be used and will be used in the future to remove greenhouse gases from our atmosphere. But we're still seeking funding for the climate repair strategies that will ensure that we can keep our planet inhabitable for decades to come. So with that, I think I will wrap up our slides here. Show you a couple pictures of our efforts to actually, these coral pictures are before and after the cooling of the waters with the water from the deep sea. And, we thought it would take 3 months, but very happy to see that in 24 hours, you give nature half a chance, she'll rebound exponentially. And in 24 hours, we saw the intervention take place and the corals retain color for weeks on end. And so with that, I will leave you with that hope for the future. Let's give nature half a chance, enable her to rebound, and humanity could just survive. Human civilization could just survive along with the rest of nature if we manage things well. Thank you very much.
Thank you, Dr. Brian, for that informative and very well articulated presentation. I am sure our audience have many questions to follow up. It it was wonderful to rediscover the magnitude of marine permaculture and its potential as a nature-inspired, nature-based solution, as you put it, across the world, and especially in the field of climate repair, with the example of coral bleaching. I assume that the method that helped the zooxanthellae to recover and the corals regain the color. So that is something new that we all learned. And I request the audience to type in the answers in the chat or maybe raise a hand. And for those of you who have joined in late and wondering who's speaking, maybe you cannot see me because of some tech hitch, but I'm the moderator, 𝐁𝐫𝐢𝐚𝐳. I will start with the question about ocean acidification because just as the uninhabitable planet graph that you showed us, there is another one which shows the dead sea zones around the world, right? So can marine permaculture be a solution to this ocean dead sea zones as well?
Yes, it can. One of the key aspects of marine permaculture is its ability to draw down the nutrients from even the surface oceans. And that is a key aspect of balancing our imbalance. When we have too many nutrients going down the rivers, it's a serious problem called eutrophication that results in these dead sea zones. By drawing down those nutrients before they reach the sea with freshwater permaculture and after they reach the sea with marine permaculture, we can reduce those zones, and that would be very helpful. I think it's important to realize that when it comes to corals, in the future, ocean acidification can be an issue. But today, the water's too warm, and that results in thermally induced photobleaching, which means the high temperature of the water results in the corals being very sensitive to too much sunlight. And the result is that the corals bleach and often die. So the clear and present problem today is ocean warming. In fact, I have to share with you that the year the IMO regulations went into full effect, January 2023, within 6 months, the North Sea surface temperature was 5 degrees Celsius above normal. And the first coral reef I ever dove on, which was the Sombrero Reef some 50 years ago, didn't bleach, it just died in August of 2023. And I'm very sorry to have seen the first love of my life, and that is the beautiful corals of the Sombrero Reef gone. And in fact, we have an expert here, I believe, Tom Garreau, who can speak more to the coral challenges that we're facing. But for me to hear that many, if not most, of the corals of the Florida Keys are now gone because of this inadvertent IMO experiment of vast scale. Well, it's very sad to see these casualties. But it's also showing us the way, because at the end of the day, when it comes to political action, we've gone so far in the last 40 years, and business as usual, right? Not just talking about it, but not really doing it. We're about 30 years beyond the stage where emissions only reduction would have been enough. And in fact, even the carbon removals will take maybe a dozen years to reach a gigaton for marine permaculture and a dozen other climate wedges. So what can we do within one election cycle to actually get us back to healthy climate? It's going to rely upon climate repair. And many of our colleagues say, look, at the end of the day, the only solutions are going to be ones that can be initiated and developed in an election cycle. And that means we must consider and research and develop the climate repair solutions, especially those that are nature-based or nature-inspired. And for me, nature's way of cooling the planet is to have bright, fluffy cumulus clouds. I think restoring the level of those clouds locally and regionally can enable local citizens to really make a difference by showing an example for cities around India, saying we've had enough with this ministry for the future. We want to have a healthy climate now. And so that's something we can vote. We can vote for in our municipalities, in our local regions. We can do local climate cooling to bring back the monsoon to levels that it was at just 10, 20 years ago. There's no reason that we can't address this locally and regionally. And this is how I see our theory of change proceeding. And that's why activism in local and regional areas across the Indian subcontinent is so impossible. It's so critical because it's a matter of survival. From Australia to India, a matter of survival today. Thank you.
Thanks, Brian. So glad that you pointed that out. It is about saving the human race from Australia to India and everywhere else. It's not about saving the planet, which will always be there. We do have a comment and a question from 𝐁𝐫𝐢𝐚 here. And he says, excellent presentation of an important initiative. Global potential is evident in your Philippines and India activities. Could you please explain the plans for local fisherfolk and farmers to manage and maintain for decades and even expand these platforms?
Yes, thank you very much, John. We are working with local seaweed farmers and fishermen today with our flagship system depicted behind me in the central Philippines near Cebu. And you'll notice over my shoulder a few sardines every now and then popping up because they love the habitat and the food that is provided by the seaweed each day. We see this as an excellent model to restore the livelihoods of sardine fishermen because they need, these sardine populations. When there's 1 billion sardines, the school of sardines is the habitat. But there's been a lot of overfishing and actually a loss of the supply of the plankton that they eat as well, the algae. And so if you don't have 1 billion sardines, they need a forest for habitat. And that's where the marine permaculture comes in. So I will say from the Philippines to Australia to India, the challenge is to restore those habitats, to regenerate healthy habitat and food production. In the tropics, we've seen a loss of photosynthesis 30 to 40% because of ocean warming. The result being less photosynthesis, and every other breath we take, half the oxygen production on the planet is coming from the marine algae. And so the challenge and the opportunity is to really extend these principles to India, starting perhaps in Tamil Nadu, extending to Lakshadweep. And we could see going to Gujarat and across the Bay of Bengal to actually enable the restoration of productivity and livelihoods, not only for seaweed farmers, but also for the sardine fishermen to enable the coastal communities to thrive once again. So that's how we see evolving this and really enabling the livelihoods as well. At the same time, we'll document the climate repair. Thank you.
Thank you. We have another question from Aditya Sharma, a microbiology BSc student, and he is asking how can we as students can contribute to this cause and what kind of research options and can we look forward to integrating seaweed farm and phytoplanktons in our ecosystem?
Yes. Well, I think there are several things that can be done, and that is to encourage these discussions and presentations. I know that Dr. Sumitra Das has done a tour across India just in recent months discussing climate repair solutions and choices for India to make. And for, I think it will happen on the local level and the regional level first, because there will be municipalities that decide to take action, and that's going to be very important. I think we've actually been working with student groups from the University of Delhi and other universities across the world to actually develop solutions in India and beyond that can work for the seaweed farmers, that can work for the rice farmers who depend upon having good productivity as we go forward. And I think there's an opportunity to study these applications, to popularize them, and to encourage more discussion along the lines that Dr. Sumitra Das and others with the Healthy Climate Initiative have been developing in just recent months on applying these things. Because, you know, I I think it's fine to research and develop some approaches, uh, but ultimately, I think it's going to require leadership from the low latitude nations. And I think the leadership is going to start at the municipality level and the regional level, where the problems are the most severe, and maybe initially along the coastline. But then even the marine clouds have a profound effect hundreds of kilometers inland. And, you know, here in Australia, John may know this, 95% of the population lives within 100 kilometers of the coastline. And in India, I think there's major populations near the coastline as well. So let's start there. Let's see how we can go. And I think as students, there are probably three things: to understand the technology, to understand the marine biology, yes, but perhaps the most important change we can make is not the marine permaculture, but the social permaculture of how do we make decisions collectively as a people. And I would like to see us apply the dozen permaculture design principles to our social frameworks of how do we bring together circles of wisdom that enable us locally and regionally to make wise decisions about our future together. Thank you.
Thank you. I am curious about the suitability of marine permaculture in different geographies. For example, you are working in the tropical areas. Would it also be possible to regenerate the kelp, which is dying out in some areas of the Antarctic, or maybe the seagrass in Europe and other areas?
Yes, that's a great question. We have seen, it's a year-round problem in the tropics because, the water's too warm and there's a barrier to that upwelling year-round. But now we're seeing as far north as Japan and Canada, and as far south as the tip of Tasmania, losses of up to 95% of the kelp forest because of the seasonal uh, warm water that occurs in the summer and the autumn. So it's a year-round problem in the tropics, but it's a seasonal problem in the temperate regions and the kelp forests. And of course, the kelp, the perennial giant kelp, lives 3 to 7 years. So it has to survive each summer on a starvation diet. And the challenge is, can we use marine permaculture? We have early evidence that it does work to actually keep the kelp forests alive from the shores of California to the tip of Tasmania. And we have more and more interest from countries like Japan, who have shown leadership by saying that seaweed is a true blue carbon sink and will be included in their nationally determined commitments across Japan. So we're encouraged by this, and we look for other countries like India to also account for their millions of tons of seaweed production anticipated with Modi's mandate to actually include seaweed and other blue carbon sinks in their nationally determined commitments under the Paris Accords. Thank you.
Thank you. I think someone was trying to speak. Could you please speak up now?
Yes, I was just trying to ask one follow-up questions to this thing. So my concern is that this marine permaculture effort, do we need to integrate also the other global problems like changes of amok? That is also changing the total ocean situations, as well as that many these coral reefs are dying because of the anthropomorphic reason, in the sense that people are using certain chemicals in their bodies when they're going to the sea, and there's some little percentage of these things also killing the coral. I think that this might have also some corresponding effect on the kelp. Kelp is also some kind of seaweed, I guess, but in the bigger thing, it must be having some effect on this thing. So,
yes.
and also I'm having idea that there are a lot of ocean acidification is happening because of the huge carbon dioxide in the air. And this is creating a acidic situation is also maybe counterproductive to the kelp situation. And that way, what can we as a community or investors and communities can do to overcome all this problem, and how we can integrate entire this process of ensuring that. Yes.
That's a great question. And I think there are many assaults on the corals and our ecosystems all the way to kelp forests and even Greenland. It's important to prioritize. It's triage. We're living in an age of triage where we have to care for the sick and the dying, and we have to identify the opportunities to make a difference. Now, with corals, there are many assaults on corals, but perhaps the most acute assault is the ocean warming is resulting in thermally induced photobleaching, which means it is today, I mean, yes, ocean acidification will be a problem. But today, the corals are dying because the water's too warm and they become too sensitive to the light. So if we can address the ocean temperatures through regeneration of marine clouds, through sea spray aerosols, and these are healthy biogenic aerosols. If you look up and down the coast, during the day, you'll see a haze near the shoreline, and it's the natural sea spray. And there's been quite a lot of study of how fires and other problems cause problems for kelp forests and seaweeds, but very few people know the profound effect that seaweeds and other algae have on the regeneration of marine clouds. It turns out that in the picture just behind you, there are some marine clouds up in the sky, and the brightness and the extent of those marine clouds depends quite a bit on the algae in the ocean, as well as the sea spray. And thus, by restoring, well, I'll say this, in my home state of California, Mark Twain once wrote, the coldest winter I ever spent was a summer in San Francisco. And part of the reason for that may have been that no one alive today has a living memory of the kelp forest that existed in the 1850s, but the US Geologic Survey created maps of all the kelp forests existing in 1853 and in subsequent years off the coast of California. And they were continuous rivers of kelp, almost a kilometer wide, that extended from Central California to the Mexican area border. So we know now the profound role the ecosystem services that these ecosystems have to rebrighten our planet. And yet we've lost most of them. And so that's a real challenge. Now, I believe that if we are to address the Atlantic meridional overturning circulation and address the disruptions that are likely to ensue, we will need to use nature's inspired solutions of rebrightening ocean planet Earth, one region at a time, one locale at a time, to actually reduce the melting of Greenland and to get us back to healthy sea ice and healthy marine clouds to protect us with the monsoon clouds in the summer. So I would say from the tropics of India to the Arctic regions, we must rebrighten ocean planet Earth physically, morally, and intellectually. Thank you.
Thank you for enlightening us.
Great.
Just another question. Actually, do you suggest that we should do this kelp farming even in the deep ocean if possible? Because if we create certain buoy, the entire ocean is available to us. No, because there also it is possible.
Yes, I'm reminded of the furry little mammals that were at the very edge of the planet during the Cretaceous. And when the giant meteor came and destroyed the dinosaurs, they then spread across the continents, and now we have the mammals ruling the earth, right? So think of the seaweed forest the same way, right? A little sliver, 500 meters wide around the edge of the ocean is where it survives today. But with marine permaculture, we're designed to work in all waters greater than 100 meters deep. And that means 90+% of the oceans are accessible to marine permaculture, including most of the Bay of Bengal and most of the Arabian Sea. So imagine if we could regenerate. We've been trying to keep our planet alive with one arm behind our backs, right? Because we're only working on land. But most of the tropical ocean is empty. And by regenerating the primary production that we've lost due to ocean warming, and regenerating that primary production at least to pre-industrial levels, we can work to have the food productivity, the habitat, and restore the fisheries. And, like I was saying, give nature half a chance, she'll rebound exponentially. For our upwelling systems, we have seen thousands of sardines. We have seen hundreds of tuna fish. We have seen dozens of dolphins spend more than a month around the platform, and even 2 whale sharks came to eat the algae around our platform for 3 days. So nature has voted with her fins, and she said, "You have got a good solution," and she loves it. So I think we just need to scale this from a small quarter hectare to thousands of hectares in the Philippines and millions of hectares across the Indo-Pacific Ocean. And this will truly be an exponential rebound for nature. That's our sincere hope.
Thank you, Brian. You give us so much of hope. We have another question from Mr. Peter Lindenmayer, and he is surprised by the high productivity of the big grow product compared to fertilizers. And his question is, can you explain what in big grow accounts for this? Is this high productivity sustained over a number of years? And are there any obstacles to the large-scale use of this to replace or reduce chemical fertilizers?
Well, thank you, Peter, for that question. It is a fascinating result that the seaweed foliar biostimulant is so transformational in terms of productivity. And, it's interesting. I sat down for lunch with the chief scientist of one of the seaweed foliar biostimulant companies, one of the biggest and longest standing companies in the world, running for 50 years. And he shared with me over lunch, he said, there's not enough. I mean, there's a theory. There's a plant growth regulators that are helping to stimulate the plant that actually improve the immune system of the plant. And the theory was you spray the biostimulant on the leaves in the morning, They go in through the stomata of the leaves and upregulate the gene expression of the plants and improve the uptake of NPK fertilizers into the plants. And that's a good theory, but we're applying only 1 liter of biostimulant per hectare of rice per week. And he says, there's not enough plant growth regulators in the seaweed there to actually explain everything that's going on. And so the answer is we actually don't know. And we are writing proposals to understand what's going on. The theory is that, seaweeds are an incredible prebiotic. In fact, I take a little bit of seaweed every day, and look what happened to me. You know, it's a prebiotic that is healthy for the gut microbiome and likely also healthy for the plant microbiome and maybe the soil microbiome. And my guess is that it's the interaction with the microbial communities, that is resulting in this productivity. But the reality is, the experts really don't know why it works so well, except that the improved uptake of the fertilizers, of the nutrients that are in the soil, are profound. And I will share with you what I've learned just in the last couple of weeks, and that is groups across the states and across the world have looked to determine when we grow our vegetables, our rice, our grains, our crops, what is it that really determines the nutrition that's in these crops? And it turns out they looked at organic, they looked at pesticide free, they looked at different fertilizer levels, they looked at all these different variables, and they were not getting very good correlation at all. But the one greatest correlation that they found between of the nutrition in the vegetables and the effects under our control, it was the life in the soil. That when we have life in the soil, the more living the soil is, the greater the nutrition in the vegetables and the plants. And that tells me that we need to work hand in hand with the rest of nature to ensure a living soil. And by measuring the respiration of our soils, we can actually improve the nutrition in our crops. So I view that as an inspiring direction for the future and really an opportunity. And in terms of limits to scaling, uh, we have high productivity already. We have deployed 3 transportable seaweed biorefineries. Just in the last months, we received an award from the United Nations Development Program, UNDP, to develop the 3rd biorefinery, which we have now completed as of the end of March, so just now. And each one of these biorefineries can produce thousands of liters of biostimulant per day, suitable for tens of thousands of hectares of rice, mango, and other crops. So this is ready to scale. We're ready to scale across India, across the Philippines. The Philippines imports 4 million tons of rice every year. And there was a scare in the price of rice in Japan. It spiked because they were short of rice. They import a lot from Vietnam. And the next meter of sea level rise, 40% of Vietnam's rice production will be inundated by the sea. So truly, climate disruption is an issue of food security for humanity across the world. And what we must do is to enable these kind of solutions to scale now. And we are hoping to stand up a seaweed foliar biostimulant business in India that can help to supply, because if we can just have a 10% effect, the rice supply for India, it's 1 billion people, with rice, and these little small 10% changes is like 100 million more people having food security during these times. So it is so important for us to scale this now, and we would like to reach out and help develop these sustainable public benefit enterprises across the Indo-Pacific, including India. And the time is right now because of Modi's mandate, because we now have full-time staff in India and the opportunity to connect with the agricultural supply chain companies in India to enable this solution to be spread quickly. So we look forward to finding partners and enabling the solution. The future is here today. It's just not broadly distributed yet. Thank you, Peter.
Thank you, Brian. We have just passed the 1 hour mark, and but we do have another question in the chat from Ronald Larson. If you could quickly take that. Can you expand on the economic of returning cold water to save coral?
Yes.
I think that would be the last question for this
One
webinar.
question. Can I ask one more question, Raj?
Yeah, go ahead. Yeah, please go ahead.
Okay, after Ronald.
Okay, Ronald, thank you for that. I was surprised. We did some studies for the city of Muscat in Oman. They asked us to help. In their city, 70% of the electricity used by the city goes into cooling. More than half, just for cooling the buildings, refrigerator load, etc. And they're only 22 kilometers away from deep, cool seawater that is at 5 degrees Celsius. And I will say the same is true for cities across India. It may be a little further, maybe 30, 40, 50 kilometers, but the deep sea is right nearby. And so when it comes to economics, imagine reducing or removing most of the electrical load of these cities. That is the first economics. And so we were describing the value chain, right? It starts with the deep sea water, cooling the cities, then producing fresh water. Like Lakshadweep today, a dozen islands have the deep sea cooling coming up, and they use the cool to condense fresh water from multi-stage flash distillation. And that gives them fresh water for the islands, a critical freshwater supply. And after these processes of cooling and fresh water, we go to the corals, and we have some early trials, but very limited funding so far, to study that if we just cool the corals off by 0.5 degree with a cold water pipe around the edges of the corals, recovery if there are storms, we can actually reverse and even prevent bleaching locally on high value reefs. And then once the water is fully warmed, we take it offshore into deeper water, irrigate the seaweed forest, and produce the seaweed that Modi has mandated. So there's our value chain right there. And, you know, along the lines, we have the coral benefit. Maybe the coral aren't paying us directly, but I would suggest we need to move from not only the financial capital building, but also the environmental capital of rebuilding and regenerating our coral reefs. And I will say the social capital of building our civic institutions, of building our educational system, of ensuring that we have the educated population for the next generations that is well versed in the art of social permaculture that will help our local and regional governance for years, if not decades to come. And that's why civic action is so important across India today and across the world, starting with students, of course, and continuing. And that's why the work of Dr. Sumitra Das and the Healthy Climate Initiative is so important, to really bring the message of hope that exists. It's the reality today. And we must be the change that the planet needs on a planetary timescale of just a few short years. Thank you.
Thank you, Brian. I really like the sound of that Modi has mandated, because without political will, we can never get to the scale of replicability and scalability. The potential cannot be reached without political will, and India has the ability to lead the way. Can we go to Dr. Sumitra Das for the last question?
Okay. Thank you so much, Brian. So wonderful presentation. Just quick understanding, what that Modi's mandate? Are there any grants associated so the people can take advantage if they want to?
There are some grants that are being put forward, and there's some interesting challenges. Of course, there's Bureau of Fisheries, other government agencies have been working to make this work, but you know, they're spending lots and lots of resources to produce just a 3 by 3 meter patch of seaweed off some places in Tamil Nadu. And we proposed, with the private organizations in India, we proposed a system, not 3 by 3 square meters, but 100 by 100 square meters for 10 times less the cost.
Mm.
The challenge is, can we cut the bureaucracy? Can we encourage the government to govern, and the private institutions that are 10,000 times more efficient to come forward and, you know, actually get the grants? So this is our challenge now. We have a little bit of private funding, but we have to encourage the government institutions to work with the private sector to ensure good use of the funds to actually scale the sustainable public benefit corporations that will enable sustainable scaling. So it's, I think, working with the government and some bureaucracy to encourage the good use of the funds in the months and years ahead to fulfill Modi's mandate. So it's an ongoing challenge. If people have expertise in this area, please reach out to us, because we're working hard to, and we tried a project in Gujarat just a few months ago, but I think all the funds maybe went to the government. So now we're working with stakeholders in Tamil Nadu, in Lakshadweep, and in Andhra Pradesh to begin projects there in places where we can make some progress and have, let's say, a public-private partnership, really, to enable sustainable scaling and a fulfillment of Modi's mandate.
Let us talk offline on this and see how we can work together on.
Wonderful. Thank you so much for this opportunity. Really appreciate the chance to address this pressing need. And I believe the leadership really will come from nations such as India. We must start at the local and regional scale, where we can act sooner rather than later.
Well, thank you. I think it has been a very informative, very engaging webinar. The quality of questions coming in for the participants has been very, very good. You know, we have got so much answers. Of course, the takeaway for me would be that it is not just finances, but we need the political will, because there are nature-inspired, nature-based, as Byron put it, solutions out there, especially marine permaculture. The potential is immense, and we need the political will to actually implement these quickly across the world to save the human species from extinction, to put it, you know, to really put the threat into perspective. Now I hand it back to Mr. Ghoshal, the host, for the concluding part of the webinar. Thank you.
Thank you so much, Mr. Rituraj. Thank you especially to Dr. Herzen for your compelling insights and for showing us what's possible when innovation meets ecological wisdom. We have heard today how marine permaculture offers a powerful blueprint for healing oceans, enhancing food security, and sequestering carbon, all through regenerative, nature-aligned methods. That's really wonderful. And a special thank to Mr. Rituraj, who has skillfully guided us through this fascinating and important conversation. As we reflect on today's session, let's remember one important point, that ocean holds immense potential, and not just as a resource, but as a resilient partner in our fight against climate change. It's up to us now to amplify these solutions, support these missions, and act with urgency and purpose. Thank you all once again for joining us. Let's stay inspired, stay involved, and let's work together towards a sustainable and hopeful future. Thank you.
Thank you, everyone. Have a wonderful day.
Thank you.